Alrighty, my friends, we're going to evaluate the integral of e to the negative 2x sine of x from 0 to infinity, and it's going to be awesome, but there is a trick to it, and I'm going to show you how it's done. Now, we're going to solve this using integration by parts, which is the most popular method. There's actually a different way to do this that I prefer, but watch this method and then check out the other way, and then you decide which method that you like better. Okay, so we're going to set u equal to e to the negative 2x, and dv equal to everything else, sine of x, d of x. Now we're going to take the derivative so that du equals negative 2 e to the negative 2x dx, and then integrate so that v equals negative cos x. Now we'll take these and plug them into our integration by parts formula to give us this. So this is u times v, evaluated from 0 to infinity, minus the integral of v du. Now both of these are negative, so they cancel out to make it positive, and this minus sign, I brought it inside the integral to make it positive here. And this first term here is going to be 0, because as x goes to infinity, this becomes 0. Cos 0, this becomes 1. So this whole thing is negative 1, but there's a negative here, so these two negatives make it positive, so this term is positive 1. Now, if we look at this side here, that's what our integral is equal to. So we have 1 plus the integral of negative 2 e to the negative 2x cos x. We need to evaluate this. And to do that, here's the trick. We're going to use integration by parts again, a second time. So u equals negative 2 e to the negative 2x. This is our u right here. And dv is everything else, cos x dv. Now if we take the derivative, du equals 4 e to the negative 2x. And if we integrate, v equals sine of x. Now if we use this, plug it into our integration by parts formula, this is what we get. So this 1 comes along for the ride. Now if we look at this term, as x goes to infinity, this goes to 0. And sine of 0 is 0, so this whole term is 0. So that's cool. And if we substitute what I is the integral we're trying to evaluate, so this is what our equation becomes right here. And if we look at these two terms, they're the same. So we can actually combine these two terms together. We'll transpose this to the other side so that there's a 5 here equals to 1, and divide both sides by 5 to literally give us our answer, and we're done. Now, this was a lot of work, right? Integration by parts twice. There is a much easier way to do this integral that I really prefer, is way better. You should definitely check this out. Good luck in your midterms, final exams. You can survive.